Okay, going over our Chapter 14 physics test. Problem number 1, how much potential energy is needed for a spring with the spring constant of 730 newtons per meter to stretch 1.5 meters? The equation is PE equals 1/2 kx squared. That would be 730 newtons per meter times 1.5 meters squared. If you multiply those together, you get about 1600 joules. Number 2, tapping the surface of a pan of water generates 17.5 waves per second. If the wavelength of each wave is 45 centimeters, what is the speed of the waves? So, frequency is 17.5 hertz. Wavelength is 45 centimeters. And our equation, velocity is frequency times the wavelength. If you change the 45 centimeters to meters, you would get 7.9 meters per second. If you left it the same, this unit is incorrect, but it would be about 790 centimeters per second. The third one, wavelength, is here. The crest is up here. The amplitude is the height right here. The trough is down here at the bottom, that's B. Okay, what is the period of a pendulum? That is the equation T equals 2 pi times the square root of L over G. So that would be 2 pi times 130 centimeters. Well, no, it has to be in meters because G is in meters. So here you could use 9.8 or 10, either or. You do have to convert 130 centimeters to meters. There you get about 2.3 seconds. That is the period. Okay, on the back, number 13, if you're considering the equation for pendula, T equals 2 pi times the square root of L over G, this question asks, a grandfather clock keeps time with a pendulum. Which will be true of the clock if the pendulum is shortened? So we are shortening, or making this number smaller. Therefore, this square root is going to be smaller. And overall, our period is going to be smaller. So if our period is shorter, the clock will run fast because the seconds will be incorrectly too short. Okay, and the last one. If we consider the equation V equals wavelength, lambda, if we keep the wavelength constant, as the velocity goes up, the frequency goes up. And here are the answers to the vocabulary. And that's that.